Welcome back, students. In this video, we shall be talking about quadratic functions. Quadratic functions. What are quadratic functions? How do their graphs look like? And what is their form? And how do we identify? If you have to sketch, what are the things we are expected to do as far as the plotting or the sketching of the graph is concerned? Now, quadratic functions have the form f of x is equals to ax squared plus bx plus c. That is how they look like. I mean, that is their general form. If you look at this, obviously you know that this is a general form of quadratic equation. Okay, so that is how quadratic functions look like. Now, but note our a must not be equal to 0, because the moment a is equal to 0 here, if you put 0 to be a here, it will no longer be a quadratic function. It will now become a linear function. Because by the time a is equal to 0, everything will be 0 here. So we left with bx plus c. Now, the graph of a quadratic function, the graph of a quadratic function, is always what? A parabola. Is a parabola. And has a maximum point and has, when we see parabola, there will be maximum, there is minimum point. Has a maximum point when your a is less than 0, and the minimum point, please take note of that, and a minimum point when your a is greater than 0. We will see this in our graph now. Let's show this in the sketch. Let's show this in the sketch. Now let's show this in the sketch. You can draw this. Is y is x axis. So let's see we have this. Let's draw it like this. So let's have something like this. Yeah, that's the first one. That one looks like a cup. But the next one will look like a cup. Okay. Yeah. So here, let's extrapolate it down to the x-axis. So we call this one h. Let's extrapolate this one to the y-axis. We call this one k. Okay. So the points are the coordinate point there is h, k. Don't forget this is our what origin. Now this one we have the form f of x is equal to ax squared plus bx plus c. Our a here is less than 0. So that is for the one that has a maximum point, the coefficient of your x squared, a here, will be negative. But for the other one that has a minimum point is just the opposite of the first one. So these are what? This will be h, this will be k. So invariably minus minus k. So h, k. The h is the equivalent x-axis here. Y this is the y-axis. So f of x here, that is the function, is ax squared plus bx plus c. But our a is what? Is positive. Our a will be positive. One other interesting thing we should remember here is the domain. Okay, the domain of the function. Now, the domain of this function, let's write it there. The domain of this function is a set of real numbers. While the codomain or the range is minus infinity, k. You may be wondering, how did I get my? Don't forget that we said the range of a function is always a set of y values. So now the domain of a function is always a set of x values. You can see, looking at the function, you can see that the x axis there, at the point we have h for x. Are you following now? And at the point here we have k. Now this point is the maximum point for all y's. So that means we have several other values, several values of y that we cannot list here. Yes, that's why in the range, which happens to be the for y, we have minus infinity. That coming down here, we have several negative values. Yes, for y, because if this is okay, this is positive, going down, you'll be having negative values of y. So that's why we have the range of the negative value of infinity. Then, and we consider we close it. Okay, k is the maximum point of y. That's why it is closed here. Now, but for the range, I mean for the domain, it doesn't have a closed form here because the value of x increases largely. Then this one, the domain of this function also, just like that one, is what? Is a set of real numbers, while the range of this function is k then minus okay, that should be k infinity, not minus. Yes, let's look at it. We know we are talking about the values of what? The values of y. Okay, the minimum values of y here is minus k, because this is a minimum quadratic graph, minus k. So there are several other values of y. That's why we are considering the close to be positive infinity. Because if you leave, suppose y is minus 3 here, minus 2, 0, 1, 2, can see it goes on and on and on. So the minimum point, the smallest is minus k. But as far as this this particular one is concerned, I wrote minus k here just to actually show you that it's negative. But when you want to write it, it will be k then together with the negative, the positive infinity. Sorry. So let's look at how we can solve a problem there, so as to understand this concept better. But by and large, that shall be discussed in the second video. Click on the notification buttons so that anytime I produce new videos, you will be duly notified. Stay blessed as you watch the next video.